Okay, so let's talk 3D printing. So for this, I'm going to kind of break it into three sections. We're going to start off and I'm going to go over the physical printer itself, the different components of it, how it works, how you need to prep it before you start printing or between prints, how to keep an eye on it to make sure it's not going to ruin all of your prints or break or something like that, as well as just how to start prints and how to adjust some settings on it. So we'll go over some of the parts first. I'm gonna turn my camera here. Barry, could you give me a hand? Just quickly. Here is your printer. It's a standard Cartesian printer, which essentially just means it works in X, Y, and Z, instead of some of them you get that use weird methods of 3D printing things. These ones are the easiest and the least likely to break. They are essentially 4 stepper motors and a piece that gets hot. It's a glorified hot glue gun with motors on it. You have your X, Z, and Y motors in back, and then you have your extruder motor, which just does nothing but push filament through this piece here, which gets hot, the little nozzle at the end. That's the main breakdown of the printer, really. Besides, this is your print surface. This is where everything will start, and it needs to be particularly clean. So you can't do this. Don't do that, because any grease or any dirt that gets on that bed will basically make your prints not adhere to it and make it really hard to do anything. Your printer has 2 methods of inputting data onto it. You can either use a small SD card or USB to put data onto the printer, so you can put your files on it, print them. And I guess from there we'll go into how to start it up. On the back of this printer, you have your main power switch right near the power cable. And I'm gonna show this here. Then you have your control right here. This is basically the only information the printer will provide you, and it only has 1 dial and a button. In here you have your 4 main options: print, prepare, control, and info. Info just tells you the current model of the printer, the firmware, everything like that. Control allows you to specifically adjust the heat of the bed, the heat of the nozzle, how fast the extruder is extruding, all of the really fine-tuned stuff that you generally don't have to worry about. And prepare allows you to do things like disable the steppers, digitally move all of the pieces, so you can move it forwards in the Y or in the X or Z. You can auto home the printer, which will bring all of the components to their limit switches. Both X, Y, and Z all have small limit switches here, which basically define the outside of the bed. So it won't attempt to print outside of hitting those limit switches and a certain distance from them. Now, you can also do your preheating for different plastics here, your cool downs. You'll need to do that for adding or removing filament, and I'll show you how to do that soon. Down here, there are your current temperature, 21 degrees Celsius, just room temperature, which is followed by your target temperature, which is where it is trying to reach. That is both for the nozzle and for the bed. You have your current speed. You can turn the speed up and down, and the Z offset. So sometimes you may want it to start printing at a certain offset if you're continuing a print or something like that. In terms of turning a print on to start a print after you've done all of the modeling and slicing, it's as easy as just selecting print, choosing whichever file you have from your SD card or USB, and hitting start. After that, it will start printing, and all you have to do is watch it to make sure it's not going to fail. So your main issues you're going to run into when printing something, the main issue in general is it's not going to adhere to the bed, which means it's going to attempt to extrude plastic from this tiny nozzle here as close to this bed as possible, and it's just going to not stick. It's going to slosh around. You're going to end up with a whole bunch of just wasted plastic all over the place, and it's a fire hazard. So that's caused by mostly two issues. One is your bed is dirty because you've been touching it, or it's not level. So down here, you have these little wheels. There's one on each corner, and they are connected to springs. Those are used to level the bed, so you can turn one of these up or down, and it will adjust the angle and canter of the bed. And that will allow you to line it up so it's as flat of a surface as possible, because you can't align your nozzle. That's always going to be in the plane it is. You have to make sure that this is aligned to it and as close as possible. Generally, the best method of doing that is to put a piece of paper on your bed, auto home your printer, which takes a second. From there, you can disable your stepper motors, and this is the position where your nozzle is going to be as close to the bed as possible. It's going to be your start position. And when the piece of paper is between the nozzle and the bed, you should be able to move the piece of paper around with a small amount of resistance from the nozzle. So basically, you're going to have about the width of a piece of paper, the thickness of a piece of paper between the nozzle and the bed. And you're going to do that for every corner and the center. And as you go around, you're going to find that there's certain spots that are too loose or too tight, and you'll adjust the wheels, each wheel accordingly, to make sure it is the correct, just a little bit of resistance. And you'll have a level printer. Then when you can go around that, and there's even resistance around each corner and the center, your bed's leveled. Beds will occasionally come mildly warped, which means they won't be perfectly flat, and it will be impossible to perfectly level them. And that's just something you have to work around when you're laying out your prints on the bed. That's a software thing, so we'll cover that a little bit. In terms of how it actually prints objects, a printer prints in layers. So it starts at one layer, finishes that, moves up very slightly, prints another layer on top of it, and you end up, I don't know if it will show this very well, but there are lines all down and up and down your print. So because it prints like that, your Z-axis is your most delicate axis. It means it's the easiest way to break, like the easiest way something's going to break. It's all your weak points. So if you have something that's printed very tall, it'll be easy to kind of snap in two. This one's too thick. But if you print something that's very short, so I printed these in two different orientations, one printing up and one kind of on its side. This one here has its layer lines going this way, but they are much longer, so it's much stronger. It's less likely it's going to snap into pieces, sort of like this here was printed straight up, and that means it's the weakest point. It's snapped off right along those lines, and it ends up being a reasonably clean snap off. The prints are also generally hollow with an infill, which means that they have this strange kind of grid inside of them. Them being hollow makes them mildly weaker, but it also saves a lot of time and filament because it takes a really long time to print things, especially if they're completely solid plastic. And I think that's most of the printer overall. Jared, would you say that there's anything I missed going over the physical aspects of the printer?
No, didn't really notice anything. I'm also playing with mine right now, so.
So I think the next thing I'll probably go over is how to design something for 3D printing and the things you have to take into consideration. So I'm going to share my screen. And share my SolidWorks. So is everybody able to see this okay?
Yep.
Awesome. So this is just a random part, a CSWA practice part. And if we wanted to 3D print this, there's a few considerations that need to be taken into account. The first one, if we were designing this from scratch, is what is used for what, in terms of, does this hole exist as just a hole for looks? Is there going to be a rod going through this that it has to spin on? Is it going to be something that's screwed into? What is the purpose of that actual hole? Say like this little piece that's popping out here, is that going to be holding any weight? Does it need to fit onto something? Because all those, with anything that needs to interact with another part, be it 3D printed or a bolt or anything else, you need to take into account the tolerance of the printer. Because when the 3D printer, say, follows this curve, it is following this curve exactly with its nozzle, which means it is essentially following a 2D line. And 3D printer, like this line to the 3D printer is essentially zero thickness. But when it prints, it is not zero thickness. It is printing out at whatever your nozzle width is, the standard nozzle width being 0.4 millimeters. So very small, but really noticeable depending on what you're doing. So as it prints along this line, it's going to put the center of the nozzle on that line, and it's going to squeeze. It's going to end up having slightly thicker, it's going to have a 0.4 millimeter line there. So approximately 0.2 millimeters is going to be on this side, 0.2 millimeters is going to be on this side. So this hole is actually going to be slightly small. And that goes for basically every line on here. It's either going to make everything slightly small or slightly bigger. Very slightly, but if you're trying to fit a rod through this hole that's exactly 5 millimeters wide, you don't want the hole to be exactly 5 millimeters wide, because when it's printed, that hole is going to be 4.8 millimeters wide. If that makes sense. So you have to give anything that's going to be interacting with physical parts at minimum a 0.2 millimeter tolerance. So if I would make this hole slightly larger, 0.2 millimeters larger than the rod that would fit through it. Unless, say, I had a hole that I needed to screw into. It needed to actually catch the threads of a screw, then I might make the hole exactly the same size as the screw or slightly smaller, depending on how well I wanted it to grab in there and if I wasn't worried about it breaking. You also have to take into account the way that the printer prints in layers, because as it's printing up in layers, it's going to have a maximum resolution. So when it comes to curves, it can't make a perfectly smooth curve. It has to make a bunch of layers stacked on top of each other. So you're going to end up with, let's do this. Instead of ending up with a nice smooth curve, you're going to end up with, like, this will be your first layer. That'll be your second layer. That'll be your next layer. That'll be your next layer. And you end up with like steps, which generally isn't too bad unless you're doing something like a through hole that needs to have a pin go through it so it can rotate. Because then your through hole isn't going to be round. It's going to be almost an oval, because it can only do, if we started off with like this, it's making it semi-round. And then your top and bottom are always the largest parts, and they're always flat. So you end up with kind of an oval shape. So you have to take into account that any holes you print sideways, if you were to print it in exactly this orientation, that's not going to be a perfectly round hole, and you're not going to be able to perfectly fit something through that. And you can account for that by making it slightly larger, changing the shape of the hole very slightly, or you can account for that in print orientation, which we'll go through in a second. Another big one, much like with the different little squares I showed where you have the layer lines, you have to think about how it's going to be taking force and what could snap off the easiest and orientate it that way. So if this little round thing here had to have force applied to it, something hung off of it, I wouldn't want to print it like this, because then the layer lines are going to be running across it and it's just going to snap right off the body, the main body of the thing. I want to print it like this so that the layer lines run this way and they are kind of perpendicular to the force. You also have to take into account the printer can't print on thin air, so it has a limit to what it can print overhanging air. So the general rule of thumb is if you are printing an angle like this that goes up, you want to print, or you want it to be a 45-degree angle, because the printer can make a 45-degree angle just go climb straight up, no problem. An angle like this, it's probably going to have issues because as it comes through it, it makes this. It's going to start off and then it's going to start trying to go further and further out. And then this area here is just hanging over thin air and it's just going to droop down and it's going to be a really uneven surface. So so when you're designing anything, before you start designing, if you're planning on 3D printing it, you should think about not only how, like, you have to think about what is going to be having a force applied to it, what has to interact with other physical objects, especially if they're other 3D printed objects, because then you have to take into account the fact that the layer lines could be rubbing together, and that's going to cause quite a bit of friction. And you have to think about the overall orientation to make sure that none of your curves are going to be impossible to print, or you don't have any overhangs, so you don't have something that would stick out right here with nothing underneath it, because then the printer is going to be here and then try and just print over thin air and then stop midair, and it's just gonna all fall down. One last thing you have to do is basically designing to overcome one of the downfalls of 3D printing and the bed. In order to stick to the bed, the 3D printer purposely makes the nozzle slightly closer to the bed than it should be. So it takes the thickness of the piece of paper we used and it cuts that down a little bit so that it gets a really good squish against the bed of the printer. But what that does is when it squishes more, that 0.4 millimeter extrusion that I mentioned earlier ends up becoming slightly wider. And what that does is at the bottom of your print, your bottom, instead of being exactly where it is, it's going to look a little bit like this. And it's going to kind of stick out a little bit more because those bottom layers were squished a bit more than they should have been. And that's called elephant's foot, is when it makes it kind of extrude too much on the bottom. And it's annoying and it makes for weirdly sharp edges, but it's really easy to fix because after you've planned your print, you know what orientation you're going to print it in, you know that none of the angles are going to be like impossible to print. You can add a chamfer to your bottom edges, and they just need to be 1/2 millimeter. If you can add a 1/2 millimeter chamfer to each bottom edge, that will generally get rid of any elephant's foot, any extra squish that's going to be there, and it's going to make it a lot nicer for you to print it. Means you're not going to have to worry about sanding down the edges or anything like that. One thing to note when it comes to needing to print over angles that the printer can't do by itself, or printing overhangs like I talked before, you can add support when you're slicing the print, and I'll show that in a second. Support is basically extra material that the printer will put in place so that it's anywhere that it would be printing over thin air, it's now printing over this extra support material that's meant to be taken off later. So if we were to print this in this orientation, it would automatically place support all through this area, as well as in this hole, underneath this, and entirely under here, up to probably this point. So all of that would end up being support material, all of which you need to rip out and cut out after you finish your print as a post-processing. And it's not nice, and it leaves generally really ugly marks on your prints. So while sometimes necessary in order to print something, if you can design your item with design it to require the least amount of support material possible, that is always the best case. even if that means, can't erase that now. Adding a lot of, just a bunch of extra chamfers around so that where it has to go up and over, it's now going kind of at an angle, a 45-degree angle where it can do that. There's also, I don't have a good way of showing it on this, but depending on the printer, you also have the option to do something called bridging, which essentially goes against what I was saying about printing on thin air. So if you're printing, say, a house, and you have two walls on either side, you need to print across this area, but this is a closed house, so you can't have support material inside because you'll never get the support material out. Depending on how toned the printer is, how well set up the printer is, the type of plastic you have, the temperature of the plastic, and a lot of other factors, you can actually stretch the plastic from its starting point here and stretch it across here almost perfectly straight. And you'll end up being able to kind of bridge the gap and create a solid surface across it without needing support underneath. In my experience, it's generally safe to get about 2 centimeters of bridging. It depends on the printer. I haven't tried much with the Success Center printer here, but it's something you can play with when you're designing stuff to printing, and give it a try and see. You'll usually get a little bit of drooping on the bottom layer, but if it's inside something, it's not really going to be noticeable. Let's see. Just make sure I'm not forgetting anything. Oh yeah. So the printers, 3D printers obviously aren't very large. The one we're using has a bed size in X and Y of 220 millimeters by 220 millimeters approximately. So you have about 22 centimeters of play. So if you are designing something that needs to be larger than that, you need to split your designs, because you're not going to be able to physically print it generally, unless you want to print it in a weird orientation that may make it a lot harder. So be careful when you're designing anything that needs to be printed larger. I found a good method is to design it as the full piece, use the SolidWorks intersect tool, and then add fins or tabs or something small where they can be slotted together. And then you can, after the two pieces are printed, you can slot them together with some glue, and you'll usually have a pretty sturdy piece. Does anybody have any questions about modeling for 3D printing before we start talking about slicing 3D prints, converting prints?
Yeah, I have a question.
Yeah.
So you said that the nozzle is about, did you say 0.4 millimeters?
Yes.
Okay, and do you ever like use different size nozzles, or is that like very standard?
0.4 is the standard. Any printer you buy generally will come with a 0.4 on it. It's the most often used because it's easiest. But you can't actually get nozzles up to, I think I've seen some over a millimeter in width.
Okay.
which means your prints are going to be extremely low resolution. The print lines are going to be huge. It's going to be kind of, it could be kind of flimsy in terms of like cracking off along those lines, but it prints really fast because
Yeah.
your nozzle and everything is moving at the same speed, but it's outputting so much more plastic.
And so how does that relate to the diameter of the actual filament that you need to buy, if at all?
What do you mean, sorry?
Like do you need to buy a specific diameter filament for your nozzle?
You might
One
have
point seven
to,
five versus like 2.75, I think is what he's asking.
yeah, if you, depending on how large you get and the hot end you're using, you may have to get a thicker gauge of filament. I think once you get over a millimeter, you do have to move into the I think 2.75 diameter filament.
Okay. So like what would be the diameter of the filament you're using now?
1.75.
1.75?
Yeah.
Okay. And so it becomes like the nozzle reduces that diameter. Does like thermal expansion play any role in terms of like shrinking after it cools down?
Yes, actually, that's an issue I met with pretty seriously last summer during one of my projects. It's really noticeable when you're doing large prints, very wide prints that are not very thick.
Okay.
And what happens is as it prints, so say you're printing a square the entire size of the bed.
Mhm.
As it prints, the inside, the center of the bed is generally the warmest part, where the outside is slightly cooler. And because of that, as you're printing, the edges of the bed being slightly cooler, that plastic cools slightly more than the inside, so it contracts slightly, and that leads to curling on the edges of your print. And you'll see them sometimes lift off on the corners or on the sides of the print and just completely come undone. With those, you have to generally find a method to keep the printer hotter. Usually that's done with an enclosure, and that will prevent it'll keep a more even heat distribution along the bed. Or you can use adhesives to keep it on the bed. A lot of people use hairspray. You can use stick glue, stuff like that, to kind of counteract the curling.
Okay. Cool. Thank you.
But in terms of a standard prints, if you're worried about it like shrinking down below the size it should be when you designed it, that's generally not a big issue.
Yeah. So it ends up really being about 0.4 millimeters after it comes out, like for the final product.
Do you mean like the line or?
Yeah, like any given cylindrical line, like the
Oh, it
nozzle would
ends
extrude.
up, depending on, again, how well calibrated your printer, it ends up being about 0.2 millimeters larger, because it's about half the width of the filament, or half the width of the extruded line.
It ends up becoming larger than the nozzle diameter.
No, it's like the nozzle diameter is 0.4.
Mm-hmm.
So you'd end up say you're trying to print something that's exactly 10 centimeters.
Yeah.
It may end up being 10 millimeters. It may end up being 10.2 millimeters. It'll be about an increment larger that's equal to about half the diameter of your extruder.
Okay. Like let's say though that you're literally just extruding one like single like one-dimensional line.
Yep.
What would be the diameter of the line?
Then it would be 0.4 millimeters.
Okay.
Or
Cool.
whatever the width of your nozzle is.
All right, thank you. You can continue.
Anyone else have any questions about designing things so that they can be 3D printed?
I have a quick question about like the so I know we have more 3D printers like located in the FSD, like I believe like some of them are under threes and stuff, but like what differentiates those ones from like the one we have in the Success Center, and like why would you use those for design alternatively?
Sorry, I couldn't hear that one super well. Were you asking about the difference between like the Success Center 3D printers and some of the other printers in the building?
Yeah, and then like how it like would impact like your design for design.
Yeah, no, good question. It depends. Some of the printers we have, some of the nicer, just like standard printers, could be running with upgraded hot ends or updated motherboards, which allow them to supply more power and get hotter. And that would allow them to print in different kinds of plastic. Like you could use ABS, nylon, stuff like that. And that just changes the kind of the material properties of what you're printing. A lot of the basic print considerations, the basic design considerations stay basically exactly the same. With a few changes, say, I think ABS doesn't bridge quite as well from what I remember, and it is more prone to curling. So you do have to kind of take into consideration what kind of plastic you use, but that's one of the big things with some of the better printers we have is just more options in terms of your materials. And then there are printers you can get that have dual nozzles or dual extruders. And those can be used, I think specifically the one we have here, where you can print the main piece in your main material, the plastic that you want. And then all of the supports can be printed in a dissolvable plastic. So instead of having to manually tear out and like break out and clip off these supports, you can dunk it in liquid and have all the support material just melt away. So if you have some really complex designs that you need to print that need support materials on the inside of them, that would be a really good time to use some of the big printers.
That's pretty cool. Like so if I was like, say, I don't know, I had a 3D printed part for my design, would I just choose the easy option and go Success and 3D printed off, or like what would be like, how would I like decide with the benefits of the other printers worth it? Like I guess you kind of described that, but like what would be like breaking it down to your main considerations? What would it be?
My main consideration would be, what do I want it printed out of, and how fast do I want it printed? If it needs to be printed at a really high tolerance, like it needs to be exact, it needs to be made out of ABS, it needs to be printed in the next week, then that might be a time where you say, okay, maybe I should go and see if I can put in a work order for one of the printers in the additive manufacturing lab. If it's something like you're okay with it being printed in PLA, which is the standard plastic we're using in the Success Center, you want it's within a single printer size, like it's not overly massive. You're okay with the infill structure being slightly less to save material, then that would be a time when it might be best to say like, yeah, I can get it whipped up at the Success Center in a day. But if it needs to be like really high tolerance, really high quality plastic, or if it needs to be, say something like really large, then it might be best to see if you can get a work order from the additive manufacturing lab.
Awesome, thank you.
Any other questions? If not, we can move on to how to slice your models, how to actually convert it from your solid part into something that the printer can understand. The first step to that is to save your model as a more standardized file. So for that, we're going to just save as, And I'm gonna save it as CSWA practice 1, and you're gonna want to save it as an STL. You can, there's a few other files that work. I think steps work as well, but STL is the standard for 3D printing files. And save, and this will just basically convert it from a SolidWorks part to just straight geometry. Now I have to adjust my screen share. One sec. So the slicing program I'm going to go over is called Ultimaker Cura. It's a free open source slicer software made by the company Ultimaker, who makes 3D printers. And it is a pretty great software. It's a little difficult to get used to. There's a lot of options, but everything's basically there right off the bat, everything that you need. And it has methods of turning down its intensity. You can set it to beginner mode. You just give it a file, tell us, just say, yes, I want supports. No, I don't want supports. And it'll just give you something to put on the printer. But we'll go over some of the methods you can use to enhance your prints, just alter them to make sure that they're going to be as good as possible. 1 second as it loads. Okay, so this is Ultimaker. So right now, we have it set up to work with, I just have a custom setup right now. It's called a Creality Ender 4. Technically, we're using an Ender 3 V2. So you can set that to just Ender 3 or Ender 3 Pro, and it'll use all the correct settings. It scales the bed to be the same size as the physical print bed, as well as giving it this little grayed out area, which is, it is adjustable, but it's kind of like a safety space. It says, even though the bed is this wide, don't print in those gray areas just in case it runs into something. So once we get Cura open, it's as easy as selecting a file to open up in the corner and opening the STL you made earlier. And it loads it into its little Cura space here. It generally, I find it usually loads it in weird positions. Like this would be a terrible way of printing this, because you can see the blue parts are what is on the print bed, and any part that is red requires support material. So right now, basically the entire thing needs support material. Very little of it is on the print surface. That's not good. So if you click it, you can go on the sides. It gives you an option for translating it, resizing it, either uniform or ununiform. So you can make it really long, really wide. And you can rotate it about any axis, as well as a few extra nice features like align face with build plate, lay it flat, reset it. You can mirror things. You can change some settings for different models, because you can give it multiple pieces at once and have multiple things to print. Cura will almost always have this default to a 0.4 millimeter nozzle with a generic PLA plastic. That is exactly the settings you want, unless for some reason that's been changed. So what we're gonna do is we're gonna briefly rotate this into the position we talked about earlier, where it's easiest to print and where we're happy with it. So you can see there's red here, red inside this hole, some red there. So right now we could hit slice and it will break this down into G code, which is essentially coordinate code that the printer reads and moves to. It'll say extrude this much at this location, then move to that location. And if it was to be printed, this is what it would look like. Your red being walls, yellow being top surfaces, and this kind of blue being your support material. So we just have standard supports turned on, and you can actually on the side pull it down and see how it would print it at every layer, down to watching the nozzle actually go and move through the entire print. And here you can really see the hollow structure. So let's say this is going to be, we'll start off with some, oh crap, no, cancel. Let's start off with some basic settings. So on the side, right here, you can open up your printer settings, and this little 3-bar line will let you choose how advanced you want your settings to be. Be them extremely basic, you want to be able to just chuck it on here, slice it, print it, done. To expert, where you might have, certain walls, or you might be taking extra torsion or something, so you make the walls thicker, you may have more infill, stuff like that. And all of these little things are changed. All these little drop downs are things you can change from your quality, which is generally measured in layer height, which is the space between the actual physical layers. Your walls, which is how thick your walls are, how many lines there are. Those are generally related. So if you say there's 3 lines, it's going to adjust the wall thickness automatically because the walls are going to be 0.4 millimeters thick. And then horizontal expansion, so you can make things a little bigger, compensate for some stuff. You have top and bottom thickness, the number of layers that exist on the top and bottom before it starts printing infill. The main one is infill itself, which is your infill density. You can turn down. A lot of the time people will turn down infill. If you're just making a very quick prototype, it doesn't need to be sturdy, it just needs to be the correct shape, because reducing infill saves a lot of plastic and makes it a lot faster to print. You can do the same with removing top layers and bottom layers. If it doesn't need to look great or function perfectly, it just needs to be the correct shape. You can turn down top layers and it's just going to save you a lot of time in plastic. For your materials, whatever material you're printing in is going to have an optimal printing temperature and an optimal build plate temperature. For PLA, that's generally 60 degrees on the build plate, I find is the best, and 200 degrees Celsius for the nozzle temperature. You can turn up or down the speed that the nozzle will actually move around as it's printing. One of the downsides to turning up the speed, I mean, upside, obviously, it prints a lot faster. Downside is there's a lot more potential for errors when printing. You could have spots that just don't extrude correctly. You may have spots that end up becoming just big blobs. The print might fail completely. Travel is an interesting section because it's, guess the best way to put this is the nozzle is constantly under pressure, which makes sense because we are forcing 1.75 millimeter filaments through a 0.4 millimeter hole. So because it's constantly under pressure, we can play with traveling settings, which basically say, as you're going along a wall, when you get to 3/4 of the way through the wall, stop pushing filament through it. Just let the existing pressure in the nozzle extrude the filament left in the nozzle. And that will prevent you from putting too much plastic down when you're traveling in a straight line or coming towards a corner. Because if you don't reduce that pressure, you can end up with large blobs of plastic where you shouldn't have any. So that's kind of your traveling settings. Retraction will actually go a step further. And along with just stopping pushing more filament out when it gets to a certain point, it will pull some filament back and reduce even more pressure. And that means you don't have to travel for as long, which saves you a little bit of potential for error. And but does slow down the print a little bit. Z-hopping when retracting is just it increases the height very slightly in order to create a tolerance between the nozzle and the print in case there's any stringing or anything like that. I find it doesn't do a whole lot. Not that it doesn't help very much for what I've been printing. For cooling, obviously the plastic needs to cool. That's actually a part I didn't show on the physical printer, is there is actually a fan pointed pushing air directly below the nozzle where it's extruding the plastic, so that the moment the plastic hits what's underneath it, it is cooled off and hardened. So you can turn fan speeds up or down depending on if you need it to print extra hot for some reason. And then you have generate support, which in your basic settings is just, you turn it on, you say place supports everywhere, and then you set your overhang angle. So that is where I said the printer can generally print 45 degrees perfectly fine. Almost any printer can do this. So your support angle will start off at 45 degrees. So that means anything at 45 degrees will print at like with support. You can change that to 46 degrees, and anything at a 45-degree angle no longer needs support. And you can see how that adjusts it as I change it. So everything with a 4, that's everything with a 4-degree angle. Everything over a 4-degree angle needs support. That would be terrible. A lot of printers can push it. A lot of printers can go up to say like 60 degrees or something like that, but 45, or technically in this case 46, is your best support overhang angle, just to be safe. You can choose whether support to place everywhere or only touching the base plate. So if it's only touching the base plate, it means it will only be here. Like it will only be under here. All of this stuff won't have support, because directly underneath it is more like another piece of the print. That's useful in some cases. Build plate adhesion is a big one, and something to really take into consideration with the size of your print. So this is currently set to skirt, so you'll see when I slice this, it'll take a second, and preview. It generates this little skirt of plastic around it. That is the first thing that's printed. What that essentially does is preps the nozzle. The printer will always print a little purge line on the side just to make sure that the nozzle isn't clogged, but this will run before it starts printing anything inside. It's just going to make sure that the printer is hot enough, there's plastic easily flowing through it, and everything is ready to go. And it has the added bonus of you can sit and watch it print the skirt, and the moment you see that the skirt is pulling off the bed, or there's a large blob on it, or it's not extruding enough, you can just cancel it before it starts printing anything else and say something's wrong, got to fix it. Need to clean the bed, need to level the bed, need to unclog the printer, need to adjust the print for some reason, change temperatures. But occasionally you'll get to prints that are difficult because they have very little contact with this base plate. So you may have something that's standing up on legs or something like that, or is just very small. So something, if a general rule of thumb is if a piece of a print has a contact patch with the base plate of less than 5 millimeters, even 5 millimeters is a little iffy, but anything less than that is it's not going to stick. It might stick down for the first couple layers, but as it gets higher, there's going to be more force applied to it, and there's not enough surface area on the bottom touching the base plate for it to stick without falling over. So when that's the case, you can add a brim. So what a brim does is it adds an actual, it forces there to be a larger surface area that the print is touching, or that's where the print touches the bed. So if you have anything that has a small contact surface to the print bed, add a brim to it, and that will ensure that it doesn't just fall over halfway through the print or 7 hours into the print. Dual extrusion really isn't something that we worry about here in the Success Center. We don't have the options for that. But like I said, some of the larger printers in the school do have printers with multiple extruders on it. They can do multiple kinds of plastic. And it is important to note that 3D printing takes a long time, like a lot longer than you ever want it to be. So this would take almost 5 hours to print at standard quality. If you wanted this to be a really high quality print, you wanted it to look really nice. Let's see how long this will take. Yeah, it's going to take almost 9 hours now. So it's important to take time into consideration when you're designing something and how large it is, because if you need to have it printed in a day and it is huge, it might take 2 full days to print it. When we get into some of the more advanced settings, we won't go much further than advanced settings. We'll just quickly go through these. There are a lot of extras that you can change. Initial layer heights, so you can make it squish more to the base plate. Like when I said earlier that it prints the first layer slightly smaller than it should be, you can make that even smaller or even larger if you want. That is a way of reducing elephant's foot without adding chamfers, but will reduce the chance of it fully sticking to the base plate. You have line width, which you can change. That's like I said, where if you printed a one-dimensional line, it would be 0.4 millimeters. This is generally has to be the same as your nozzle size. Wall line width, same idea. Top line width, same idea. You have your wall thickness again. You can optimize wall printing order so it will print places that don't need as many walls, won't have as many walls. Fill gaps between walls. Kind of self-explanatory. Your top and bottom layers, you can add or subtract layers, change thickness. Ironing is a very nice option. What that will do is if you say wanted a very smooth surface, your bottom surface where it touches the print bed will always be quite smooth because it is it has that extra squish. The top surface generally isn't as nice as that. But if you enable ironing, what the printer will do is it will, after it finishes the print, stay at that top level, not go any higher. And then just increase the pressure in the nozzle and completely go over the top again, filling in any gaps and smoothing it out. So if you ever need to have a very smooth surface on the top, you can use ironing. You have a little bit more options with infill in the standard or in the advanced settings, where it's not just density, but infill line distance, how large the boxes are. You can change the pattern. You can do this with the basic one as well, but you can change it from, say, like cubic to triangle to lines to grid to zigzags. I won't go over all of these. They all sort of have their own reasons for using them. Some are stronger, some are cheaper in terms of plastic, some are faster to print. Some of them don't show through the walls of your prints as much, because sometimes you'll be able to see some infill through the walls. But generally, cubic is your best bang for your buck. It doesn't take a lot of plastic. It's quite sturdy. It's reasonably quick to print. You can multiply the infill lines in case you need more infill. Overlapping, layer thickness, the usual stuff. Gradual infill steps is an interesting one. So you can kind of change the infill density as you get through it. Printing temperature, you can actually set here is the printing temperature initial layer. So you can use this to print. It does that for the build plate initial layer too. So that is the first layer. You may find that you're having trouble sticking a print to the surface for whatever reason. But that's the only layer that's having troubles. You can increase, say, your build plate temperature initial layer to, say, 75. And that's just going to make it hotter on the first layer. It's going to stick down a little bit nicer. Final printing temperature is just where the temperature should be when it's finishing. If you want it to start cooling down before it finishes printing for some reason. You have more options with print speed as well. You can change the speed of individual parts. So you might want infill speed to be a little bit faster because nobody sees that. It doesn't matter if it messes up. And you might want wall speed a little bit slower because it needs to be perfect. So that kind of stuff. Travel speed, skirt and brim speed. You can turn on acceleration and jerk control, and that will kind of adjust for any issues in the printer. When it comes to like shaking or anything like that. Again, it mostly just slows down the print while adding a little bit more quality. You can, with travel, chain, retracted layer change, so that will pull filament back into it, reduce almost all of the pressure in the nozzle when it's changing. Again, that's going to be something that's going to reduce stringing. Stringing you'll find mostly in round holes. When it goes and travels around it, it will then like reach the end of the layer. It will then move to a different spot and it'll leave a little bit of plastic along it. And you'll have little thin strings of plastic in the hole. It's a common thing. They just break away very easily. But if you retract it layer change, you can avoid stuff like that. Retraction distance and retraction speed is sort of difficult to play with because you can do some math to find out the best distance and speed for what you're trying to do. You can do combing, which basically just, I don't even know. I've never played with that one. Retracts when the nozzle moves in a straight line. Yeah. Avoid printed parts when traveling. You always want that on, obviously. This basically just says don't run into the part that's been printed so far. Support. You can adjust fan speeds at different times. Again, if you want the prints to print hotter at certain points because you want it to either fuse better or stick to the bed better or anything like that. Build plate adhesion, you still just have skirt brim. You can use a raft, which will, in cases where things really don't want to stick, you can print a raft which essentially prints not just one layer, but multiple layers underneath the print. And basically makes an artificial print surface underneath it. And that's really good for, again, things that really don't want to stick down, because the raft will stick down even if your model doesn't want to. The downside is you do have essentially support material on the entire bottom of your prints, and it's going to be hard to remove, and it's going to lead to an ugly surface on the bottom of your print. You do also, with your support now, have a lot more options in advanced. You can use normal support structure, which will just build straight up underneath the surfaces that need support. You can change, again, placement, touching build plate or everywhere, angle, support pattern. It's kind of like the infill pattern where you can adjust it for different purposes. Support density, how dense you want that to be. If you want it to be higher density, means it's probably going to support the print better, but it's going to be harder to remove. Horizontal expansion, line thickness, and then there's roof and floor of the support. So the floor of the support will be what's on the bottom, and it will print a thicker piece, like a whole nother piece of plastic, and then put the supports, and then it will put the roof of the support, and that's going to give you the best surface on the bottom of the support, or on the part of the print that's being supported. But it's going to be a lot harder to take off, because it's going to use a lot more plastic on supports. And then my favorite is the tree support, which actually does some really fun. I'll show you what the trees, I'll show you actually the normal first. So when we preview the normal support, you can see where it just builds straight up on what exists there already, or on the build plate. And if we skip and change that to tree support, and let it load, it actually does some really fun math and figures out the best way to audio and video coming out for anyone else. Are you still able to hear me? Oof. Unfortunately, I don't have much I can do. I'm in the Success Center on the FSDE internet. But with tree supports, you can see there's a lot less material generally, and it builds it a lot different. There's a lot less that ends up touching the bottom of the print, because support built on existing print surface is generally the hardest to take off. So it tries to print as much as it can, as much of the support as it can from the build surface. And it allows you to put support in some kind of weird areas. So it fixes a lot of the issues you may have when you need to support something. When you need to support like complex structures, you can use a tree. You also have a few special modes, print sequence, print everything at once. You wanted to print one part at a time. Surface mode. Where is surface mode, spiralize outer contour. You have some experimental stuff. So use adaptive layers will adjust the thickness of the layers depending on where it is in the print. That's a very experimental one, I find. make overhang printable, which basically changes the geometry to make it so steep overhangs are less steep. And there's a lot more experimental things when you get into your more advanced settings. But I don't know if we'll go over all of that right now. And the main thing is, once you have your print set up, you have your settings adjusted. If you just need to print it, you just put it on, hit slice and print. You can just save it. If you grab the SD card and SD card reader from the printer, you can pop that into your USB and it will automatically allow you to save it to your removable drive. You save to drive, you hit eject, you pull it out of your printer and you pull it out of your computer, pop it into the printer, and you can then just print it. The machine will do the rest of the work. From there, all you have to do is watch the first couple of layers, make sure that it's sticking down correctly, it's not pulling off the print surface, it's not under extruding, so it usually be clogged or the extruder might not be gripping the filament correctly. In which case you just give it a little once over, see why. Is the bed not level? Is the bed dirty? Do I need to take the filament out, clip it, and put it back through? That kind of stuff. Does anyone have any questions about the slicing? Sorry about my internet issues. Hopefully you can all still hear me. I skipped fuzzy skin because I didn't think it was that important. Also, it's an expert setting. They're in expert mode under experimental. You can turn on fuzzy skin, which will give all of your prints. It'll basically just shake the nozzle whenever it's drawing walls and give it a very weird texture. What I can do right now is potentially go over how to change the filaments and how to you're good. How to change the filaments and how to just make sure it's not clogged. Okay, I'm gonna move my camera here and try and flip around. See if I can do this by hand. So right now we are desperately low on filament. Not desperately low. We have like 100 grams there or something. So we're gonna change the filament. This is also your general the general procedure when it comes to fixing your clog is basically just taking out filament. First thing we need to do is we need to heat up the hot end, but we don't want it that close to the bed when it's just sitting at 200 degrees, not doing anything. So I like to use the move option, then just pull the Z axis up, put it at 19. Now we can go to preheat PLA. And it's just going to start getting hot. You can see, hopefully you can see, the target temperature is now 200 degrees Celsius, the current temperature 45, and then the bed temperature target is 60 degrees Celsius and it's at 27. So we just gotta wait for that to warm up right now. Oh, one thing I forgot to mention earlier. So you can, as I stated, print multiple parts at once. And a lot of like prints that you find online will take advantage of this and allow you to print some pretty complex parts. So you can print like full like ball bearings and stuff like that, or like just bearings and stuff in place. So they'll all the parts will be together and it'll print it all at once. But one thing that needs to be realized if you're designing something like that, that's going to be printed all together, or you're printing multiple parts and jamming them all into one space, is that it is hot plastic and there is tolerance on it. So it will all merge together into one part if your tolerance is not correct. If you're printing like a bearing that's supposed to spin, if your tolerance is bad on your printer, if you're printing too thick of a line, if your layer height is too hot, like too big, it's just all going to be one piece of plastic at the end of it. You're not going to be able to get it moving. So that's one thing you should take into account. Okay, our thing is heated up. Barry, I might request your help for this. I am not a good camera person. So our hot end has reached the desired temperature. So we're going to disable the stepper motors. And I'm going to take off this little handle here and get right in here. So this is your extruder motor. So this gear here grips the plastic and forces it through. So we need to remove the tensioner, which is pushing the filament onto that. So by pulling this back, we can pull that tensioner off of it and remove it. And if we pull this back, we can now grab the filament with one hand and just give it a firm yank and pull it through the printer. And that pulls it out of this Bowden tube, and you can see where it was melted inside of the hot end here. A lot of the time, if you have a clog, this is going to end up coming out just a lot of it will come out. And then you can use a small fine needle to actually poke through the hot end and the nozzle and make sure it's cleared out. So we're going to just pretend that this is a new spool of filament now, because we don't have another one to put in at the moment. So when you take your new spool of filament, you're going to load it onto the top. You're going to take the loose end out of it. You're going to snip it at as sharp of an angle as you can with the included flush cutters. These are your tool to remove all of your support material, or the most common tool. Once we have that, we come over here. There's a small hole right next to the Z screw.
Your hand's kind of blocking it.
Sorry. Yeah, there's a small hole. We're going to just force it through that hole, open up the tensioner again, and fight with it to try and get it through the other hole. Once we do that, we can force it. You can see it moving through the Bowden tube. And once we get there, we'll put the little handle back on the extruder, and that will allow you to manually move the extruder. And we're going to force the plastic through it by extruding it. Down here, you can see plastic working its way out of the nozzle. And if you're changing colors, you obviously want that to happen until it is entirely the new color. Or if you're keeping it the same color, you want it to just extrude a good amount to make sure that there's no bubbles. And at that point, you can retract it a little bit, and you're good. You're ready to start printing again. Thank you. Are there any questions on how to replace filaments? Okay. Jared, do you think there's anything that I missed with this? Or anyone else?
No, I don't think so. Did you touch on belt tensions at all?
I did not. That's a good idea. So I'll show you guys quickly. So both your X and Y are driven on belts that go to the motors. This one's kind of hidden away inside the X bar there. These come with these tensioners on either side. So you might find that your prints are looking very sloppy. The layers don't always level, like they're not always in line with each other. They might be, one layer might be slightly overhanging on one side and the other layer on the other side. That's generally because your belts are too loose. Because it's going to move and then it's going to continue moving after it's supposed to have stopped. So if you keep a nice tight belt where you can almost kind of pluck it and it makes a noise, that's going to make sure that you don't get that sloppiness in your printing. That's generally will just be an issue you'll see in like the XY will be off. If you ever find that you're having issues where layers are getting too thick at certain points, like the layer lines aren't consistent, but it's not off to one side or the other at any point, it's the entire layer. It's probably because your Z screw is dirty, and that is this metal screw that the motor's attached to that forces it up. If this gets dirty, it might have a little trouble moving up and down, and that can cause it to your layers to be a little too thick.
Another two things would be the wheels, adjusting them. That shouldn't have to be done much, but it could. And then the stepper motor for the Z screw sometimes causes the screw itself to twist. And the Ender 3 version 2 is a no for that. So Jeff has printed a couple brackets for his to keep them straighter, or you can put a bearing at the top to kind of hold it straighter so it doesn't cause misaligned layers.
Yeah, that is another issue with the printers that we have here, is that much like the bed being warped, when you purchase them. Sometimes the Z screws are slightly warped, and that can lead to some issues printing. And yes, Jared also mentioned the wheels that are on the X and Y as well, on the actual little gantries. Need to also be adjusted to make sure that they're often, they only need to be adjusted probably once a year, just to make sure that they're not too tight and that they're not wearing down, because they will wear down over time and need to be replaced. But that's it's a very rare piece of maintenance that has to be done on the printer. Whereas something like bed leveling and cleaning, that's usually that's every 2 or 3 prints. You're probably going to want to give your surface a little clean, just double check that it's leveled correctly, especially if other people have been using the printer. No problem, Luke. Have a great rest of your day. I think if there's no questions, we might be able to stop recording and call it an evening.
Thanks, Matt.
No problem. Okay.